Alright, welcome to part 2 of chapter 11 and chapter 12 video lectures. Part 2 video is really just going to address and talk about chapter 12 and introduce the idea of dependent samples t-tests. We're going to walk through most of the steps for hypothesis testing for this particular test. So dependent samples t-test is also known as paired samples t-test or matched samples t-test. And simply what we're doing here is we're comparing one sample, one group of people, on two means over time. So the same subjects, the same participants are tested more than once, and we're simply comparing those two scores. So we're still comparing two groups, however those two groups are made of the same people at different time points. So let's use the blood doping example again. But let's say we gather a group of 20 cyclists and measure race time on a 30-mile course prior to any sort of intervention. We then give all 20 cyclists EPO, the blood doping hormone, and then have them take a course again and then measure their time. And we're interested to see if a significant difference can be identified between their pre-test and post-test scores before they had the EPO and after the EPO. Because then we'll be able to say whether or not that EPO really had a significant effect on their times. So we're going to conduct a paired samples t-test. So thinking about steps 1 and steps 2. Well, step 1, state a null hypothesis. Simply put, there are no differences among the doping group on average time to complete a 30-mile course before and after receiving EPO. We're stating that there are no differences, stating who is our group, essentially the doping group, and the outcome, which is average time to complete a 30-mile course, and then talking about before and after whatever the intervention or whatever the event is. In this case, introduction and receiving of EPO. So how would you write out our null equation? Well, H naught is equal to population mean before is equal to the population mean after. That there is no difference. We expect to see that before and after receiving the EPO, they're going to have the same time. However, we can hypothesize that we think there may be differences, and if we're going to state a non-directional research hypothesis, we're simply stating that there is a difference among the doping group on average time to complete a 30-mile course before and after receiving EPO. And is stating our alternative non-directional research hypothesis. X bar before is not equal X bar after. But we might feel that we might know really what might happen and hypothesize a little bit further and specify that we think that after receiving the EPO, we think they're going to be faster. So the doping group has a faster average time to complete a 30-mile course after receiving EPO compared to before. So if we're going to state our second alternative hypothesis equation, what would it look like? Well, X bar before is going to be greater than, it's going to be bigger time than X bar after, the time after receiving the EPO. So let's take a look at step 3, which is calculating our dependent samples t-test. Ready for another gigantic formula? Here it is. The thing is, guess what? We don't have to do this by hand. Woohoo! Aren't you happy about that? So if we don't have to do this by hand, well then how are we going to get our t-test? Well, just like many other differential statistics, SPSS is great for this. And so we'll see in part 3 of this week's video lectures, we're going to talk about and show you how we're going to get our t-test for dependent samples t-test. So why don't you head on over to part 3 now to go ahead and see how we perform independent and dependent samples t-tests in SPSS.